Hi, in the previous videos in this series, we spoke about the fact that factoring polynomials can sometimes be challenging for students because there are multiple techniques and students sometimes don't know which technique to use for what problem type. So I've created the flowchart that you see here and linked it down below that helps you to see what path to use in each case. All right, so for every factoring polynomial question, the first thing you always want to do is make sure that it is in standard form. Then you always want to take out a GCF if there is one. Once the GCF is factored out, then count the number of terms. Is there 2 terms, 3 terms, 4 terms, or more than 4 terms? If there are 4 terms, and this is what we are going to be focused on in this video, the first thing you want to do is attempt factoring by grouping. So let's go ahead and jump into a question like this. So in this question, there are, as you can see, 1, 2, 3, 4 terms, which tells us that you want to consider factor by grouping. All right, so as we look at our expression, notice it is in standard form and there is no GCF to be taken out. So that means we can jump right in. All right, so the first thing we want to do is split our terms in half, 2 terms on the left, 2 terms on the right. And then we can factor out the GCF for each of those sections. So for the terms on the left, we're looking at the highest number that can go into 1 and 2, which is just 1. So 1 is the numerical part of our GCF over here. And we're looking for the highest x that can go into x to the 6th and x to the 4th, which is x to the 4th. So our GCF on the left side is 1 x to the 4th. And I don't need to write the 1, I can just write x to the 4th. And so when I divide x to the 6th by x to the 4th, I get x squared. And when I divide 2x to the 4th by x to the 4th, I get 2. All right, so now we're going to do the same thing on the right side. And so let me choose a different color here. All right, so now we're looking for the greatest common factor for negative 9x squared and minus 18. And so we have minus 9 is the bigger or the biggest, greatest number, numerical value. And then we have x squared and no x is over here. So that's all we can take out from the right side. So here we get x squared and we get plus 2. All right, now what we want to look for after we've taken out the GCF from the left and the right, if the parentheses match, so meaning if I have the same thing here and here, so in this case, my parentheses do in fact match, that is one of the factors, which is good news. So we have one of our factors as x squared plus 2. The coefficients of those parentheses, so what we have here and here, that is the other factor. So we have x to the 4th minus 9. Now at this point, we are not done yet because we need to check to see if we can factor any of these binomial expressions any further. And so we want to think about our binomial patterns, which are the difference of 2 squares, the difference of 2 cubes, and the sum of 2 cubes. And notice that this is a perfect square and this is a perfect square. So this is the difference of 2 squares, which means we can go further. The square root of x to the 4th is x squared. The square root of 9 is 3. And so we have x squared plus 3 and x squared minus 3. And the order doesn't matter there. And then we have x squared plus 2. And again, we want to make sure that everything is fully factored. So you check to see if this is the difference of 2 perfect squares or the sum of 2 perfect cubes or the difference of 2 perfect cubes. And none of these patterns are being followed here, which means that we have fully factored our polynomial expression, and that is our final answer.